Hello students, in today's lecture we are going to learn about motion in a straight line. NCERT Section 2.4 and example 2.2 to 2.3. Disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. So in today's class, we will cover first 2.4 kinematics equations for uniformly accelerated motion. After that, we will learn example 2.2 to 2.3. Kinematic equations for uniformly accelerated motion. Objective: learn equations describing motion with constant acceleration calculations. So there is some symbols and these are the various relations between u, v, a, t and s for the moving particle, where the notations are used as first u is equal to small u is equal to small v naught. So this notation are used as a initial velocity of the particle at time t equal to 0 second. V is equal to small v equal to final velocity at time t second. A, small a, acceleration of the particle. These are the notations. S, small s, distance traveled in time t second. Small sn, distance traveled by the body in nth second. Equation 2.4 already obtained gives a relation between final and initial velocities. So here final velocity is small v and initial velocity is small v naught of an object moving with uniform acceleration a. So the equation 2.4 is v is equal to v naught plus at. So this is equation of motion in scalar form. The important point here is the meaning of these symbols: initial velocity, final velocity, acceleration of the particle, distance traveled in time t second, distance traveled by a body in nth second will remain same throughout kinematics. Area under Vt curve. Here V, velocity and T, time. Look at figure 2.5. Area under Vt curve for an object with uniform acceleration. So on y-axis, or we can say on vertical axis, there is a velocity, and on x-axis, or we can say there is a horizontal axis, time. So the area under Vt curve here, the area is this one, Vt curve, and the area under Vt curve is this one. This shaded region are the area. Yes, area under Vt curve represents displacement. So this shaded region represents displacement. This relation V is equal to V naught plus AT from equation 2.4 is graphically represented in figure 2.5. The area under this curve is this one. Area between instants 0 and t equal to area of triangle plus area of rectangle OACD. So there is a two area. So first, if we talk about this one, the shaded region, or we can say this is the area of triangle ABC, area of triangle, and the remaining part, this one, are the area of rectangle OACD. So the area under, so this is the area under VT curve. This. So the area under VT curve is area of the triangle plus area of the rectangle OACD. So area under VT curve represent displacement. So just substitute the value. So it will be half V minus V naught into T plus V naught T. Here, this one. If we talk about the rectangle, area of rectangle, so this is this one. V naught is the height and T is the breadth. So V naught T. So this is area under VT curve. As explained in the previous section, the area under VT curve represents the displacement. Therefore, the displacement x of the object is x is equal to half V minus V naught T plus V naught T. So this is the displacement of a given particle, and let this is equation 2.5. But we know V minus V naught is equal to AT. So substitute here the V minus V naught is equal to AT. So when we substitute the value of V minus V naught, we will get x is equal to half A T square plus V naught T. Here V minus V naught is AT. So A into T and T into T become T square. That's why here the displacement, the relation of the displacement is x is equal to half AT square plus V naught T. So after calculation, the formula become x is equal to V naught plus half AT square. Here x represent distance, or we can say displacement, V naught initial velocity, T time, A acceleration, and T is again time. So this is the displacement x of the object, and this relation is very important. Yes, this relation is very important. So equation 2.5, x is equal to half V minus V naught into T plus V naught T can also written as like this: x is equal to V plus V naught divided by 2 into T. This one. So here v plus v naught divided by 2 represent average velocity. So just replace this average velocity with v var. So here v var represents average velocity. So x is equal to v var t, and let this is equation 2.7a, where we know v var is equal to v plus v naught divided by 2, constant acceleration only. So equations 2.7a and 2.7b mean that the object has undergone displacement x with an average velocity equal to the arithmetic average of the initial and final velocities. So from equation 2.4, the equation becomes this one: t is equal to v minus v naught divided by a. Substituting this in equation 2.7a, we get x is equal to v var into t. So here b var, or we can say v mean, is v plus v naught divided by 2 from this relation, and t is the v minus v naught divided by a from this relation. So when we multiply the both first term and second term, so there is a relation, and that relation is v square minus v naught square divided by 2a. So we can say x is equal to v square minus v naught square divided by 2a. So the new equation will be formed, and that equation is v square is equal to v naught square plus 2ax. Clear? Thus, we have obtained three important equations in scalar form. You know, scalar is a physical quantity which has only magnitude, whereas vector is a physical quantity which has both magnitude and direction. So first equation is v is equal to v naught plus at. Second equation is x is equal to v naught t plus half at square. And third equation is v square is equal to v naught square plus 2ax. And let this is equation 2.9a. Clear? This one. Connecting five equations, five quantities v naught, v, a, t and x. These are the kinematics equations of rectilinear motion for constant acceleration. Rectilinear motion means motion along a straight line. We can obtain a more general equation if we take the position coordinate at t equal to 0 as non-zero, say x naught. So here at t equal to 0, we consider x naught. Then equations 2.9a are modified by replacing x by x minus x naught. So equation become: first, v is equal to v naught plus at. Second, x is equal to x naught plus v naught t plus half at square. And let this equation 2.9b. And third equation become v square is equal to v naught square plus 2ax, 2a x minus x naught. So let this equation 2.9c. Clear? Example 2.2. Obtain equations of motion for constant acceleration using the method of calculus. So here we can obtain equation of motions by using the method of calculus. Solution. So by definition, we know acceleration is rate of change of velocity. So we can write acceleration A is equal to dv upon dt. dv upon dt. So by using the method of calculus, acceleration is equal to dv upon dt. So taking cross multiplication, so it will be dv is equal to a dt. dv is equal to a dt. Now integrating both sides, left hand side and right hand side, we get integration. Lower limit is v naught and upper limit is v. dv is equal to lower limit 0 and upper limit t, a dt. Here this sign, this is the integration symbol. So integrating both side, we get a new equation. So it will be, here a is a constant according to question, constant acceleration. So the here a is a constant, that's why a comes outside. The remaining term is dt, integration dt, lower limit 0 and upper limit t, means time 0 to t. So integrate dv, you will be get v minus v naught and a as it is, and integration of dt is t. So equation become v is equal to v naught plus at. So this is the equation of motion by using the method of calculus. Clear? Example 2.2. Further, v is equal to dx upon dt. So dx is equal to v dt. Integrating both sides, we get dx integration lower limit x naught, or we can say initial position x naught and final position x. So it will be integration x naught to x and dx is equal to v dt, initial time 0 and final time t. So it will be become this. So just substitute the value of v. So we know value of v, we already calculated in previous slide. V is equal to v naught plus at. So just substitute here. So integrate dx, so it will be x minus x naught is equal to integrate v naught, so it will be v naught t plus a dt. So when we integrate a dt, so it will be half at square. So equation become x is equal to x naught plus v naught t plus half at square. This one. We can write a is equal to dv upon dt. Acceleration is rate of change of velocity. So dv upon, we can write dv upon dt in another form by chain rule. So dv upon dx into dx upon dt. So dv upon dx, here dv upon dx as it is, and dx upon dt is what? Velocity. Rate of change of position is velocity. So a equal to v dv upon dx. So after taking cross multiplication, it will be v dv is equal to a dx. Integrating both sides, we get integration initial limit v naught and final limit v. So and v dv is equal to initial position x naught and final position x, a dx. So solving this, we get v square minus v naught square divided by 2 when we integrate this term is equal to, when we integrate dx, so it will be a x minus x naught. So solving this, a v square minus v naught square divided by 2, so it will be v square is equal to v naught square plus 2a x minus x naught. So 2 multiplied with this term. The advantage of this method is that it can be used for motion with non-uniform acceleration also. So this is the another equation of motion. Clear? Example 2.3. A ball is thrown vertically upwards with a velocity of 20 meter per second from the top of a multi-story building. The height of the point from where the ball is thrown is 25.0 meter from the ground. First, we have to calculate how high will the ball rise. Second, how long will it be before the ball hits the ground. Take g is equal to 10 meter per second square. Think about it. So, first case, how high will the ball rise? So let us take y-axis in the vertically upward direction with 0 at the ground as shown in figure 2.6. Look at here. So this is ground and height of a multi-story building is 25 meter. Now according to question, the height of the point from where the ball is thrown is 25 meter. Means from here, from point A. So when ball is thrown from A point to upward direction and ball reaches at B. So this is the maximum height. So the velocity is 20 meter per second and acceleration is minus g minus 10 meter per second square, because the after throwing the ball comes in downward direction, vertically downward. So acceleration is equal to minus 10 meter per second square at the highest point. So here highest point is point B. At the highest point, what will be the velocity? So velocity is 0 at highest point. So we know at highest point velocity is 0. If the ball rises to the height y from the point of launch, then using the equation, and the equation is v square is equal to v naught square plus 2a y minus y naught. So here the from the ground to the highest point, the height is y, and from the top of the building, the height is y naught, y minus y naught, this one, y minus y naught. So using the equation of motion, we get final velocity, listen carefully, at point B is 0. Initial velocity is given 20 meter per second, 20 meter per second square, 20 meter per second. Initial velocity is 20 meter per second plus 2 into a acceleration is minus 10 meter per second square, y minus y naught. So now we will solving this for y minus y naught. So y minus y naught is what? 20 meter. Y minus y naught is 20 meter. Clear? B is, we can solve this part of problem in two ways. Note carefully the methods used. First method. In the first method, we split the path in two parts. We split the path in two parts. First part is the upward motion, means A to B, and second part is the downward motion, B to C, and calculate the corresponding time taken T1 for upward motion A to B, for downward motion B to C, T2. So upward motion A to B and downward motion B to A. So time taken for upward motion T1 and downward motion time taken is T2. Since the velocity at B is 0, we have V is equal to V naught plus AT. So here final velocity is what? 0 plus initial velocity is 20 minus acceleration due to gravity minus 10. So minus 10 and time is T1. Yes or no? So solving this, T1 is 2 seconds. This is the time in going from A to B, 2 second time. Second, we will calculate for the downward motion, B to C. So from B, or the point, the maximum height, the ball falls freely under the acceleration due to gravity. So in that case, the ball is moving in negative y direction. So we use equation y is equal to y naught plus v naught t plus half at square. So this is important equation. Now substitute the all given terms in this equation. We will get our final answer. So y is equal to y naught plus v naught t plus half at square. We know this equation. So y naught is 45 meter and y equal to 0. V naught initial velocity 0 and acceleration minus g, that is minus 10 meter per second square. So substitute in this in the above equation, we get 0 is equal to 45 plus half minus 10 into T2 square. So solving this, we get T2 is equal to 3 seconds. Therefore the total time taken by the ball before it hits the ground is T1 plus T2. So 2 seconds plus 3 seconds equal to 5 seconds. Clear? Second method, the total time taken can also be calculated by noting the coordinates of initial and final positions of the ball with respect to origin chosen any using equation. So the equation is y is equal to y naught plus v naught t plus half at square. Now y naught is equal to 25 meter and y equal to 0 meter, and velocity is v naught is equal to 20 meter per second and acceleration due to gravity is minus 10 meter per second square. So here we have to find out the t. So 0 equal to 25 plus 20t plus half into minus 10 t square. So equation become 5t square minus 20t minus 25 equal to 0. Solving this quadratic equation for t, we get t equal to 5 seconds. The important point here is this: The second method is better since we do not have to worry about the path of the motion as motion is under constant acceleration. Thank you for your attention.